All right, so first things first, ideally you were supposed to come up, if this is your cart, you were supposed to come up with the velocity when your cart traveled a certain distance d. We used a sensor to determine how far your cart had traveled. That sensor was, for most of you up here, and then it sent sound out and it hit the back of the cart. Now, first off, you should have emailed yourself the file. Did everybody get the SparkView file? Okay. So for those of you who have the file but cannot open it, you will need to go, simply Google this, SparkView, and download that app for your PC or Mac, either one. Okay, it has a 60-day trial, so you'll be able to open it up. Then once you've installed it, email and look. Go back to your email and look for your SparkView file, your SPK file. If you double click on that, then it should open automatically in the SparkView software. Look just like what you saw on the iPads. Okay, in fact, like basically all they did was import it into this. It's like I don't know. I don't know exactly how they did it, but the exact copy. So from this, let's talk about a few things. Do you see these ridiculous jumps here on the green trial? There's obviously something wrong with that trial. So I would say don't use that one. That's like trial 9. I would say don't use that one. Try to use the other ones, because what you want is this nice, smooth incline here. Now I don't know what this group did, but they have a weird, because this curve, this should be flat. It should be a flat line, but for some reason, Sean Warren, for some reason theirs has this little dip. I don't know why, but whatever. But this is your data. Up here, this is the export or share button, and then just do export. And wherever you choose to export that, boom, it'll dump a bunch of files. Now, once your tech files are out there, they'll look like this. And for each trial, you'll have a file. So if I open up the trials that looked good, and remember what looked good, there should be a smooth slope, right? Just a perfect, nice slope going up. So I will open these in Excel, and when I do so, it looks like this. And this is kind of like a bunch of crazy gibberish. Acceleration in 3 axes, including the also a sort of a combined acceleration of the iPad itself, and then the sound levels and sound content. Obviously, none of that is necessary. You don't even really need to delete it, but whatever. Just for funsies, I'll delete it. And then we can kind of see. Okay, now let's take a look at our data. What we're looking for is just a time where our cart sort of accelerated through that one given distance that we chose. Okay, so whatever your group said, 1 meter, 0.75 meters, whatever. The way I determine that is I look at the position. Constant, pretty constant, and then boom. Now the position begins increasing. So when I see that change in position, that's when I know everything started. So I know my trial started at about 0.293 meters, which means my trial should finish, assume I'm trying for, at about 1.293 meters. So I go down and see, there it is, 1.293 meters. Okay, now I can select all of that data, and what I need to do, this 0.293, I need to select a little bit more than that, right? I need to select the next one up. because I have to do some interpolation in between there. And then this is all I need to see on your spreadsheet. You can get rid of all the extra data before and the data after. So for all 5 trials that you did, I only need to see that little window. So you could easily fit, like, I'm guessing you could easily fit 5 trials onto 1 page. Does that make sense? You don't need to out poor Dylan Valencia, second period, printed out like every page of everything. So you had like pages from Excel. Yeah, if there's any time that I ask you to do something and it seems excessive like that, call me. Okay, like, like for example on the PowerPoint, if your PowerPoint was 25 pages, and then now you're gonna print full 8.5 by 11 images of all 25 pages and use up an entire cartridge, $40 cartridge of ink, that's excessive. You should call me, because then I would say, no, I don't want you to print the whole thing in full size. I want it print it in black and white, right? So that, yeah, anything that seems unreasonable, I like to think that I'm generally reasonable, okay? And if you feel like something is unreasonable, chances are it's been a miscommunication. So contact me as soon as possible. Okay. All right. Is there done so far? Okay. So what we've done is we've downloaded SparkView, opened a view file, exported as a text file. In each one of these files, I've opened them all up in Excel, and then once I've done that, I'm just selecting the sections that I need and then copying it. What I would recommend: do not destroy anything until you're done. So what I would recommend is that you select them and then copy it into a new sheet. Do you get what I'm saying there? Right? So if I choose this, select it, copy, create a new sheet, and now I can just paste that trial. And then I can call this trial whatever. I don't know if that was trial 10, but whatever, you know what I mean. What's that? Well, whatever it was. Okay, so once I've got this, now I need to find the velocity at 1 meter. Now, do you know about these things? This was this was velocity, that was acceleration. And I think this was time, wasn't it? Do you notice anything weird in any of those?
The
Yeah.
acceleration goes down.
Yeah, what? Okay. This leads me to believe this is where they caught it. So this leads me to believe that this group wasn't trying for 1 meter. They were probably trying for 0.75 meters or like 50 centimeters. Do you get what I'm saying there? And they let it go past their endpoint. So I hope that you catch it at your distance. I hope that you let it go past your distance. Otherwise, this gets screwed up. That doesn't mean your trials would have to say, oops, let's go back and recalculate shorter distance. Does everybody get what? So let's pretend that that's what this group did. You see that right at almost exactly 1 meter, they caught the cart, and that created this wild deceleration. So then that screws up this data right here. So then what this group should do is they should go back and say, okay, well, we sort of messed up that section. So instead of 1 meter, let's break it down to like 0.75 meters. And then let's see if we can do this. Okay, so if we start off at 0.293, then if we add 0.75 to that, that should give us 1.04 or something like that, 1.04 meters approximately. So I'm looking for 1.04 meters. That's the point where I'm gonna be okay. Ooh, that's a negative. You know what? Check that. I'm not gonna go with 0.75. I'm gonna go with 0.5 because I've screwed up my process so badly. So I'm gonna go to 0.5. So that means that one's easy, right? So I need to go to 0.793 meters. Everybody cool with this? Okay. So where is 0.793 meters? See that it's somewhere in here. Okay. Now, do you see that this right here is delta X? This right here is delta V for the same thing. Yes? Does that make sense? So if I graph those things, what we can say is for this small interval of time, 0.1 seconds, I'm going to say that the behavior of this cart was consistent. Like it didn't wild. If we take a look at this, 1.8, 2.1, 2.3, 2, 1.5, there's a list here, but back up to 1.9, 2.1. Do you see that the acceleration is right around 2, maybe like 1.9 or something? And so our acceleration is pretty consistent. So I think, and when we looked at the graph of this trial, it was pretty consistent, the behavior. So then that leads me to say, whatever occurs in here should be consistent. Do is say this argument. Does it make sense to you that for any interval in between here, the ratio should be the same? That delta X over delta V should be the same for any intervals in that section. So it's kind of like what I'm saying is, if the graph of this makes a line, then any on that has the same slope, does it not? Am I losing anybody or are we okay? Right? Any point on a straight on a line should have the same slope. If that's true, then any interval on that line should have the same slope. If that's not making sense, I'm simply doing something like this. If I have a graph and I go like this, the slope, if this graph is constant, the slope of this line is the same point, which means if I take this interval here and here, and then I take this interval here and here, do you see the ratio of those intervals should be the same? Because whatever, let's call this X, let's call this V just for grins. Say delta X, delta V. This is delta X, whatever, 2, and this is delta V2. Does it make sense to you that delta X over delta V should equal delta X2 over delta V2? Casey? Whoa, is this for me? No, it's not for me. I think it's just in this room. Is anybody, have I lost anybody on this? Okay, that means I can pick any interval I want. Okay, so here's what we're gonna do. I'm gonna say that the delta X and delta V is gonna equal, right? And then I'm gonna go with my starting point, which is 0.685. Well, I'll take my point that I want. This is what I want. I'm going to take 0.793 minus 0. Running out of room. Okay, let me see. I will write over here, and I guess I'll just write in red on top of everything. So delta X over delta V. The delta X, if I do this, it's going to be 0.816 minus 0.685 over 1.44 minus 1.3. Everybody cool with that? Then I'm taking 0.793 minus 0.685, and I'm taking V minus 1.3. You see what I did there? I used the same endpoint. I used this endpoint twice. Once whole interval and then once for the interval that I need. Because by doing that, I can locate my velocity. This is a process called interpolation. Using the fact that this is a consistent behavior across this interval, and then because it's consistent, that allows me to interpolate the value in between. Okay? And you can do this on a calculator, plug all the numbers in and get what you want. You don't have to like solve everything. Okay? Questions? All right. Now, so with that, this is how you are going to calculate this. Okay? You're going to calculate that value. And then, that is the value you're going to use, you're going to compare that, compare it to your calculated V. Okay, now you calculated V with G sine theta, right? Did you also? Okay, so let me say that now. So you must find V final using energy. You must find V final using energy. So if we look at this, there is some potential energy at the top of this thing. There is some kinetic energy at the bottom of that thing. Figure out how fast the cart was supposed to be going based on your energy analysis. Okay? And you should discover something. What do you discover about the equation? Well, what did your velocity, your V should come out to be what? What did you calculate it to be? What was your acceleration down the incline? Did you guys not? I mean, you must have done this. You did it like a couple weeks ago. All right. Yeah. What?
This is supposed to be 3.2.
Okay, your acceleration down the incline should be G sine theta. Whatever your angle was. And then you know that your initial velocity was 0. See, it depends. It depends on what your incline was. So your final velocity should have been, and you chose your D, right? Your D was chosen. So your final velocity should have been 0, that goes away. 2gd sine theta. Right? That's what you should have come up with. Now, let's do this together. If this is PE, and down here is KE, this distance is D, that's theta, please set up that calculation. And remember, whenever we do these energy equations, you say MEI equals MEF. Right? The mechanical energy initial equals the mechanical energy final. That's how you address all these problems. So what type of energy did this thing have at the top of the incline? Yeah, potential energy of gravity. Vincent, what's the equation for potential energy of gravity? That's what we did here. Okay, now what do I put in for PEG? PEG equals what? We hopefully haven't lost any energy due to friction. This should be a conservative system. We did notes, we did word wars on chapter 6, right? We did all that stuff already? Okay. Potential energy of gravity. What is it? This should be on your note. Wow. Okay, so you need to get your notes to the point where you can find that quickly. That is one of the main concepts in the whole chapter. I'm pretty sure I went over that. I also did the graphic organizer where I showed that was PE, etc. So that's MGH, right? Now, Vincent, what type of energy did it have at the bottom of the hill? If it's moving. Kinetic, very good. So he left in the beginning, but he stuck the dismount. So let's go with the other Vincent. What's the equation for kinetic?
Is it 1/2 mv squared?
1/2 mv squared. So we cancel that and we get V is the square root of 2gh. Oops, so close. Are we wrong? Marcelo, you're saying no, we're not wrong. To me. What's that, Fun? Go ahead, Marcelo. No, go ahead, go ahead.
Because sine theta is equal to h over x, or since you use d, so then if you multiply the d over, it's equal to h.
There you go. Everybody cool with this? If you substitute for h, if you substitute d sine theta, boom, we have this thing that you calculated the other way. So this, using energy, we come up with the same thing. You must show this on your lab report. It yourself, show it yourself. Ha ha ha. So there. So then that value, which we just did right there, that's your calculated V. Right? Start at 2g d sine theta. And then that should give you the value that you're going to compare to this. And that's going to be your percent error that you're going to give you. All right? So then, let's talk about the whole tamale. What are we looking at? Number one, abstract. Okay? Actually, also on this one, you know how like on the test corrections we've done where other people evaluate your test corrections? Yes? Do you remember this? Okay. So over here, there are evaluation sheets. Okay? You must put the lab evaluation sheet on your lab. And then you must have 3 people evaluate your lab before you turn it in. Okay? They're going to, okay. When you lab, you don't just put a check. You put a check on whatever score you think for the different criteria, but then you have to boxes why you did that. So the criteria are 1 through 5 things: contents and format, data calculations, and error analysis. So you're analyzing all 3 things. Number 1, did they do it in the right basic format? The format's the same always. Abstract, quantitative, some sort of data calculations, Excel or graph, and then your logs. So all of those fall under that. If their logs aren't complete, if their logs aren't detailed, then you would take points off. Then data calculations. Did they find what they're supposed to find? On this lab, on their Excel spreadsheet, did they calculate the velocity at the given distance? Did they figure that out? Did they use gravity, or did they use potential energy and kinetic energy? Did they calculate the old way, using linear motion, the velocity? All of that is on there. And then finally, error. Did they do all the things that I asked them to do? On this lab, you will need to find your percent error. Okay, and you're going to use your theoretical calculation as the actual value. Theoretical meaning the one. Okay, then, so you're going to do a percent error of that. You're also going to do a standard deviation on your trials, based on the whatever, like the 5 trials do in terms of standard deviation. It's very simple in Excel. You just choose those 5 things and do the standard deviation of those numbers. I can show you that also later. Also, you're going to do the uncertainty of your measurements. Okay, whatever you measured in this, I want to know the uncertainty of those things. And then how does that affect the final calculation of your theoretical velocity? Let me say that again. You're going to look at your uncertainty for everything you measured, And then you're going to ask yourself, how does that affect the final calculation of my theoretical velocity, right? So, like, how sure are you of your theoretical velocity is what I'm asking. Okay? And then if they did that, that's the 1 through 5 there. A 5 means perfect, like, ooh, I learned something from their lab, because I didn't do mine this well. A 1 means they didn't even really address those things. They have some gibberish, they put some stuff down on paper, but it doesn't really make any sense. Okay? So those are the 3 things explained down here. This part you can just ignore this. Right? This is the old format, but you can ignore that because we have a new format and we already know it because we've got it 3 seconds. All right? Yeah?
Would this work similar to test correction where if you give them like 4 but then you
I'm
get 3?
ding you for this. So there's no threat here. Also, there's no, I mean, don't be nice because it doesn't help them, right? Because hopefully the idea is I give Sean my lab and Sean tears me a new, and I'm like, ooh, thanks. Because now, and then turn it in. So what will be due on Wednesday? Your lab will be due. I'm gonna get it, and then it's just gonna get stamped that you had something here on the day it was due to be turned in. Okay? And then you get it back. And then you need to have it evaluated and then turn it back in again. Does this make sense? So you get it evaluated. You won't get any points until it gets evaluated, And the reason why I'm doing this is because the quality of the labs are kind of here and there. Some people not really sure what's going on. Yeah.
Will we get named do they give us?
No. Like, if you got all, like, let's say I gave you mine, you gave me a 1, Lucas gave me 1s all across the board. That just means I gotta get my acting gear. To be honest, what I would do is I would give it to the first person, and then when I saw the mistakes, I would fix all the mistakes, I would fix it to this. So I'm hoping that the process is gonna refine it, because now is naggy about all the details, right? I'm gonna start dinging you for like grammar errors, stuff like that. Because if you really actually publish in a scientific journal, those kind of things, they just don't even read it. Like, reject it immediately because you were too lazy to even make sure that your grammar was correct, to make sure punctuation, all that stuff. Just standard English stuff. Okay? Questions on that part? Yeah.
So the evaluations are after Wednesday?
Yes. So Wednesday is just going to be a rough copy, right? It needs to have all these parts. If it doesn't have these parts, then that's it. Game. You don't go done. It's a 0. So you must have your abstract. You must have your qualitative analysis. Quantitative analysis, right? And in that, I want to see your percent error. I want to see your uncertainty, and I want to see your standard deviation. Because standard deviation is tell me how consistent you were in your procedure. Uncertainty is going to tell me whether or not you understand if your values are reasonable, and then percent error is going to tell me whether or not your theory matches up with your practice. And then qualitative at the very end. And that's where you're going to discuss those 3 things. You're going to discuss the percent error. Did your theory match up with your practice? Why or why not? Were the numbers, the values that you came up with reasonable? That's your uncertainty. And then standard deviation, were you consistent in the execution of your procedure? Okay? Second page is going to be Excel. I want to see all of your trials. Okay, I want to see your calculation for the velocity of each of them. If I were you, I would try to find a way to use Excel to do that, but otherwise, you might have to do it 5 times. Well, you should set it up so that all you have to do is find the interval and you'll be okay. Remember, some of you might need to adjust your distance, because if you stopped it at 1 meter, you're gonna have to go back and make it almost like 50 centimeters. Okay, and you'll have to go back and change your calculations as well. Also, make sure on this, or if you need, you can do an extra sheet. I want to see the the calcs, your dimensional calcs, and your energy calculations, right? Calcs meaning, if you need to do two pieces of paper, that's fine. And then your logs. Any part of that remains unclear? Yes?
Can you do the calculation part by hand, or do you want us to type it up?
No, that's by hand. That's fine. Only a one-off thing. Generally, if you're doing something once, do it by hand, and I want to see it. If you're doing something like 100 times or 10 times or whatever, then I want to see that you know how to use Excel to make that. With the interpolation, that's a pretty complicated process. Well, it's not complicated, but some time. So I'm not going to ask that you do the in Excel. You can all 5 of your trials. Did everyone get at least 5 trials? Okay, good. Any questions on this? So I talked a long time. Yeah.
For the standard deviation, you want it to be, or?
Yeah, you know how velocity in each one? Just do that. Okay, so I've talked a lot. Are we clear on the format here? Okay, we're clear that Wednesday is basically like your rough draft. So the most important thing on Wednesday is that you have every one of these sections, and that those sections contain what they're supposed to contain. Okay? Then after that, I think maybe I'll give you another week for the next Wednesday, and then that's final copy with 3 evals. Remember, there is no penalty if you gave them and I gave them a 5. I'm not gonna do, but be as critical as possible to help them get a perfect paper. Because basically, I want a perfect lab paper. So next Wednesday is perfect. In years past, the way I've done this, I don't know if I'll do it this year or not. If I find one mistake, I just don't grade it. You get it back, and then now you drop it in the total possible. I haven't decided yet. Okay. Okay. Any questions? So today I talked about a lot of stuff. We looked at the energy, the dimensional analysis of, not dimensional, displacement analysis of the velocity. Okay, you're going to put that on your calculation page. We talked about interpolation, which you're going to need to do for each of your trials, okay, to find out, because most of you, velocity occur exactly at one of the data points. Okay, it's kind of like you're on a graph. Technically, if you want to be sneaky about it, you could just graph them and then plot the point and get the value, which would be, I don't know, actually kind of easier if you know how to use Excel. But that's up to you. If you decide to do that and make 5 graphs, or take one graph, plot all 5 of them on there, and then find the values, that's fine. Just indicate that you know how you did that. It has all of the pertinent and important things. Remember, all graphs must have a title. All graphs must be labeled. All graphs must have units. All graphs must take up a whole page. Okay, so all of those things are still true. Yeah, and then you have the final format. All right, and we're now moving into this rough draft, final draft process, which we'll use for the rest of the year. Now that I've kind of introduced people to this. Questions?